Is 1 minute and counting. We're going to let you just enjoy this. Again, you're watching live coverage of the final launch of the Delta-2, lifting ICESat-2 into space this morning.
Water flow. 45.
LC, launch enable to flight.
Flight.
ATC-3, main power disable on.
On.
35.
Hydraulics a go.
30.
Status check.
Go Delta-2.
Go ICESat-2.
20. 15.
Topping go.
14.
Green board.
13.
There's
12,
that green board call.
11,
That is great.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff of the final Delta-2, launching nearly 3 decades of science research and exploration missions, lifting ICESat-2 on a quest to explore the polar ice sheets of our constantly changing home planet.
Now 27 seconds into flight. 30 seconds in, Mach 1, Delta-2 is now supersonic. Continuing to see good chamber pressure on the RS-27, both Veneer engines as well. Seeing consistent fuel and oxidizer injector pressures as well. And at T plus 46 seconds, max Q, maximum dynamic pressure. And at 57 seconds in, we have web burnout on the solid rocket motors, seeing good responses. And we have burnout on all 4 motors. And Delta will hold on to those motors for an additional 20 seconds prior to jettison. Now 1 minute, 20 seconds in, standing by for motor jettison. And we have good indication of jettison of all 4 solid rocket motors. Now 1 minute, 30 seconds into flight. Continuing to see good chamber pressure on the RS-27, good chamber pressures on both Veneer engines as well. Seeing stable pressures on the fuel and oxidizer injector pressures. Vehicle body rates looking stable. Now 1 minute, 55 seconds into flight. And 2 minutes, 10 seconds in. And the booster bi-level charge is fired to maintain necessary ullage pressure in the booster. LOX tank ullage pressure response looks good. 2 minutes, 25 seconds in. The booster is now beginning powered flight guidance. Body rate response looks good. And just under 2 minutes now remaining until MECO. And at 2 minutes, 45 seconds into flight, continuing to see good performance on the RS-27 main engine and good chamber pressures on both Veneer engines as well. Vehicle body rates remain very stable. Now passing 3 minutes into flight. Continuing to see good ullage pressures on the fuel and oxidizer tanks. Good fuel and oxidizer inlet pressures as well. And now 1 minute remaining until MECO. Three minutes, 30 seconds into flight. RS-27 continuing to perform well. Stable chamber pressure and fuel and oxidizer injector pressures, and seeing good stable pressures on both Veneer engines. Now passing 4 minutes into flight. Approximately 20 seconds remaining until engine cutoff. And booster has stopped active guidance in preparation for MECO. Standing by for engine cutoff. And we have cutoff of the RS-27. Vernier engines continuing to burn as expected. Standing by for vernier engine cutoff. And we have good vernier engine cutoff. And now 4 minutes, 45 seconds into flight. We've seen good separation of stage 1 and 2 and good ignition on the second stage. 4 minutes, 55 seconds into flight. Chamber pressure on the AJ-10 looks good. Body rates looking good. And we have good indication of fairing jettison. And this first burn of today's mission will last approximately 6 minutes, 15 seconds. And at 5 minutes, 30 seconds into flight, second stage engine continuing to perform well. Chamber pressure looks good. Seeing good stable hydraulic system pressure. Fuel and oxidizer feed line pressure is also looking very good. And vehicle body rates looking very stable. And 5 minutes remaining in the burn. Now passing 6 minutes, 30 seconds into flight. Continuing this first burn of the second stage. Engine performance continues to look good, seeing stable feed line pressures on both fuel and oxidizer systems and good chamber pressure. Now passing 7 minutes into flight. And now passing 7 minutes, 35 seconds into flight, seeing minor telemetry drop out, but telemetry has resumed and continue to see good performance on the AJ-10 engine, good feed line pressures on fuel and oxidizer systems, good hydraulic system pressure. Battery currents and voltages all remaining very stable throughout this first burn, and body rates on the second stage remaining very stable as well. Now passing 8 minutes into flight. And at 8 minutes 54 seconds into flight, now approximately 2 minutes remaining in the first burn of the second stage. Continuing to see very good performance on the second stage engine. Very stable fuel and oxidizer feed line pressures, hydraulic system pressure. Helium bottle pressure decay profile appears to be within family. Now 9 minutes 30 seconds into flight. Approximately 1 minute remaining until SECO 1. Now passing 10 minutes 20 seconds into flight. Seeing a slight decay in the thrust chamber pressure and fuel and oxidizer feed line pressures as to be expected for the later portion of the first burn. And standing by for engine cutoff in approximately 10 seconds. Now passing 11 minutes into flight, and we have SECO. Second stage engine cutoff. Body rates damping out well after the transients from the shutdown event.
So there you heard the United Launch Alliance launch commentator, Patrick Moore, taking you through the first 11 minutes. As you said, Mick, a lot of work, still a lot to go.
Absolutely, Joshua. You know, the team has done a fantabulous job to get here today. I can't even speak. It's I'm just
That's how exciting it is.
Yeah, I'm emotional here and exciting, but there is still a lot to go to be done to get us to spacecraft separation. As we just heard, we had SECO 1, second stage engine cutoff number 1. We're entering a long coast now, and then we'll get ready for second stage start for about 6 seconds to put ICESat on its final trajectory.
Yeah, in the meantime, we're going to send it back over to Stephanie to unpack more of the science and the research that we're doing as part of the ICESat-2 mission. Stephanie, back to you.
Thank you both. ICESat-2 is the next step in NASA's plan to study the cryosphere. Chris Gersh recently spoke with Deputy Project Scientist Tom Newman to discuss how ICESat-2 will measure the height of a changing Earth, one laser pulse at a time.
So Tom, NASA's been studying the cryosphere for a long time, and ICESat is really sort of the main mission in studying the cryosphere. Tell me a little bit about ICESat.
The first ICESat launched in 2003, and it was on orbit until 2009. The main purpose of ICESat was to measure changes in the ice sheets. Are they getting larger? Are they getting smaller? How are they changing? And the way it did that was with a laser altimeter. It sent out small pulses of laser light that bounced off the surface of the Earth and came back up to the spacecraft. By timing how long that light takes to do that round trip from the spacecraft to Earth and back again, we can figure out how far away or how near the surface of the Earth is. And by measuring the height of the ice sheet at the same place through time, you can measure whether it's growing and getting closer to the spacecraft or is it getting smaller. And what we found with the first ICESat was that Greenland is changing quite a lot, particularly in the edges of the glacier, that it's losing a lot of mass there where the ice sheet's getting smaller, and that water's being lost to sea, to the ocean, and causing sea level rise.
Now, we look at ICESat, it's done a great job, the mission's over, and now we have ICESat-2. Now, what happened between ICESat and ICESat-2? I understand there was a bridge. You had to keep on taking measurements between the ICESat and ICESat-2?
That's right. After the first ICESat mission ended in 2009, we knew we had to keep monitoring how the cryosphere was changing for ice sheets and for sea ice. And ICESat-2 is on the horizon, but was quite a ways away at that point. So what NASA decided to do was to use an aircraft mission, which they called Operation Icebridge, to continue to monitor those places that were changing rapidly. They use the P3 aircraft as well as the DC-8. They do about a month-long campaign or 2-month-long campaign each spring in the Arctic, and a similar length campaign to monitor places in Antarctica. With an airplane, you can fly many instruments. They use a laser altimeter, similar to what we use in space, as well as radars and cameras to measure those places in the cryosphere that are changing rapidly.
Any ground instruments that you use to measure the elevations?
You know, places like Greenland and Antarctica are huge. You can't really credibly cover much of that on the ground. They're simply too big.
Right.
But a natural question is, how do you know that the measurements from the aircraft or from the spacecraft are correct?
Okay.
So what we've done is go to Antarctica, near the South Pole, where all of the ground tracks from ICESat-2 converge. ICESat-2 will be on orbit. It goes up to 88 degrees north and 88 degrees south around the Earth. So we went to 88 degrees south, and we took some high-precision GPS instrumentation to make a detailed survey of about 300 kilometers of the ice sheet. Now, that survey is going to be one of our main reference data sets. So when ICESat-2 passes overhead and gives us some data from that area, we can compare the two and see how we're doing. Similarly, IceBridge, the aircraft campaign, flies over that same stretch of Antarctica, so we can compare the ground-based to the airborne to the spacecraft.
Now, I understand ICESat-2 is a much better satellite and a much better instrument on board. Tell me the difference between ICESat-2 and the original ICESat mission.
You know, with the original ICESat, we had never done that before, have a laser in space to measure changes in ice sheets, and we learned a ton. We learned that the main action is around the edges of the ice sheets, but as importantly, we also learned that we could monitor sea ice with that. And by measuring the height of sea ice and comparing it with the height of the ocean that you can see in these cracks in the sea ice, you can figure out how thick that sea ice is, how much is sticking up out of the ocean. And we didn't even know we could do that with the first ICESat before it launched. So for ICESat-2, we used those lessons, and ICESat-2 will do a much better job of measuring changing glaciers around the edges where it's rough and it's steep, as well as measuring sea ice freeboard as that way to get at the thickness of the sea ice.
In addition to the cryosphere, I understand ICESat-2 is going to be taking elevations of a number of areas around the globe. What are some other things ICESat-2 can do?
So from the vantage point of space, you really see the whole planet. Although ICESat-2 is really designed to measure changes in the cryosphere, the ice sheets and sea ice, from the vantage point of space, you see forests. We'll measure the height of oceans, height of deserts, all over the whole planet. We have data products that cover each of those different types of surfaces. We have vegetation data products, ocean height, ice sheet height, sea ice, etc. The cryosphere is our primary objective, so the other targets are secondary, but we think they're going to be really useful for those communities.
So is it fair to say that with ICESat and IceBridge and ICESat-2, will you be able to predict down the road, I mean, just how much the poles and how much ice is melting and how much of the ocean levels are increasing over time?
Absolutely. So with ICESat-1 and now with ICESat-2, we'll be able to measure those changes in ice sheets and measure how much mass is being gained or lost in different places and how that's affecting sea level. But you bring up a good point that our data will allow ice sheet modelers to make better predictions of the future. And the way they do that is by comparing their model prediction for right now with our data. So if a model is predicting that a glacier is changing this fast or that fast, they can compare their prediction with our data to see how the model is doing. And by calibrating their models with data, it gives us more confidence in their predictions going forward when they're predicting out 100 years or 200 years. If you're getting the modern changes right, it gives you confidence looking ahead.
We are about 17 minutes into the flight of the Delta II rocket carrying ICESat-2 into orbit. Our Tori McClendon had the opportunity to speak with NASA ICESat-2 program scientist Tom Wagner to understand why we study the polar regions of our home planet.
Thanks, Stephanie. So Tom, what exactly is ICESat-2?
ICESat-2 is a laser altimeter in space, orbiting the entire Earth, but it's optimized to study the Earth's polar regions.
So why is it so important for us to study the Earth's polar regions?
I know they can seem so far away, but the fact is the change that it's occurring there affects the entire planet. Loss of things like the sea ice that covers the Arctic Ocean affects our weather, and loss of ice that covers Greenland and Antarctica raises sea level.
So what exactly are we looking to gain from this mission?
One of the things we're trying to understand are the specific connections, the climate drivers of the change in the polar regions, so we can do a better job with forecasts. And ICESat-2 has been optimized specifically to capture those changes with things like its 6 beams and its orbit.
Okay. So what exactly is the difference between ICESat and ICESat-2? I think you touched on it a little bit.
So ICESat was a laser altimeter that was in orbit from 2003 to 2009. It had a single laser beam. And what was important about it was it showed us that the ice sheets were definitively losing mass and the sea ice was thinning. ICESat-2 has got 6 beams, so it's going to give us a lot more data. And on top of that, the lasers fire at a much higher repetition rate, so we're going to get a lot more data in each of those beams. When we put all that together, we're hoping to much more strongly tie the changes that are occurring in the polar regions with the climate drivers.
So what about you personally? You've been working on this mission for about 10 years now, is that right?
I have, and some of my colleagues have been working on it for even longer.
So how excited are you to be here now on launch day?
So everybody is ecstatic to be here. A lot of people on the team even brought their families along. But what we're also excited about is that since we've been working on it so long, we're starting to realize that there's going to be a lot of other uses for the data beyond even what we have planned. So stay tuned for some exciting science.
We're all looking forward to it. Thank you so much for joining us.
Thanks for having me.
Back to you, Stephanie.
ICESat-2 was launched into space by the last Delta II built by United Launch Alliance. Launch commentator Mick Waltman from NASA's Launch Services Program had the opportunity to visit the ULA plant factory in Decatur, Alabama, to speak with 31-year veteran Dana Vandersall about the legacy of the Delta II.
I'm so excited to be here at the United Launch Alliance's rocket factory and the chance to walk down this facility and see where the historic Delta II has been produced. Dana, that has to be exciting for you also, this final Delta II coming up. Can you tell me a little bit about yourself and how you got started in this business?
I got started at the very beginning, a little prior to Delta II in Pueblo, Colorado. Started in Pueblo, Colorado. We started with the last of the 6 Delta Is. It was coming back from where President Reagan had decided that we needed to bring back Atlas and Delta again from the shuttle explosion. And then we did the last 6 Delta Is. As we were doing that, we were working on this new Delta II. And it took a while for the first one. I think it took us about 10 months in the factory to build the first Delta II. So it was a kind of a conglomeration of Delta I and Delta II. In Pueblo, we built about 120 Delta IIs in Pueblo. And we transitioned here in 2004. And we built another 30 or so Delta IIs here.
You talked a little about Pueblo, Colorado, right? The early Deltas or Thor missions, which Delta had evolved from, were built in the Huntington Beach, California area, and then in Pueblo, Colorado. And then you talk a little bit about transition here to Decatur, Alabama, where the Delta IIs were made, right? Final Delta II, ICESat-2, that's out there on the pad. That's got to be really exciting, historic mission for us at NASA and for United Launch Alliance. Share a little bit about what you've done to prepare that vehicle for its final launch.
Well, first off, I'm very, very fortunate to have been able to work on every single Delta II. And to prepare that launch, we took extra care on the last 4. We weren't in full bore production, so we took extra time, and the last 4 were very special to us, and we spent adequate time, and they were special. We knew they were the last ones.
You know, McDonnell Douglas, who started the Thor Delta IIs, Boeing, and then now United Launch Alliance, unique thing they did, right? You work in the production area, but whenever there were problems at the pad, you guys got to travel down to the launch pads and do repairs on the vehicle as production engineers, right? So tell me a little bit how that was, going to the East Coast at Complex 17 and the West Coast at Space Launch Complex 2.
Oh, it was a great experience. And they did that because we were experienced with the build problems, and we put in all the parts. So the thinking was, if it's more than a simple change, we'll just get the guys out that normally do it and keep that experience base. So it was spectacular when you go out to the launch sites and get to work on a launch site. It was really special.
Awesome.
And the whole group, we were always kind of a small group, so we really weren't like a job or anything, we were like a family.
That was unique. You were sharing some stories with me earlier about how small the group was in Pueblo and transitioned here to Decatur. I mean, you stay in touch with a lot of those guys, or a lot of those guys still work here with you?
Yeah, I still, of course you make lifelong friends and you still stay in touch. And
yeah, you know, when we were walking around, what I noticed was how involved people were with Delta II production, how excited they were with the Delta II vehicle itself. There's a lot of memories with it, and you guys took a lot of pride in the work you did. You mentioned you took a little bit longer time on these last 4. You know, NASA bought these last 4 in 2012 for our 4 missions, OCO-2, the Orbiting Carbon Observatory, SMAP, the Soil Moisture Mission, and JPSS-1, our Joint Polar Satellite. And now, of course, our last one, ICESat-2, which is our ice monitor. We're excited to have Delta II launching these, and you know, it's been a workhorse for NASA over the years. And reliability, let's talk a little bit about reliability. Delta II is one of the more reliable rockets that's out there, right? You guys hold the world record for most successful launches in a row.
That's true, and we're very proud of that. And one of the things that helped us get there was science missions. To me personally, science missions were very personal because I knew many, many times that it would take 30, 40 years for the technology to mature before you could get a good satellite up to do what you wanted to prove. We knew that when we'd meet the scientists and stuff, they'd come and look at the launch vehicle. They had all their budget, their whole career was tied up in this one launch. So we would try to make them as perfect as possible, and we would be kind of OCD going over them and checking them. I'd drive people nuts, but our team, we'd put them together and we'd just try to make the best product we could. And in the science arena, she's done probably 50-some science missions. 8 or 9 of those have gone to Mars. I mean, when you get years ago, when you're working on a Mars mission, you're like, wow, this is special. It's very special.
You know, we talked a little bit about that world record. I had mentioned that earlier, and you know, when ICESat-2 launches, that will be the 100th successful launch of a Delta II. That's got to be exciting for the folks at United Launch Alliance and yourself as part of the production team.
Yes, it is. It's quite an accomplishment. We're happy and we're thrilled, and we're all looking forward to that 100th mission. Go Delta II.
The primary instrument on ICESat-2 is the Advanced Topographic Laser Altimeter System, known as ATLAS. Blair Allen spoke with the ICESat-2 Instrument Project Manager, Danya Douglas Bradshaw.
Danya, a lot has been made about the improvements between the ICESat mission and the ICESat-2 mission. You've been working primarily with the instrument, the ATLAS instrument. What is the ATLAS instrument, and what are the improvements that that instrument brings to this mission?
ATLAS is a laser altimeter. It's an instrument that is about the size of a smart car, weighs about 1/2 ton, and it has 2 lasers. I like to call it a sophisticated stopwatch. It can measure the changes in ice elevation down to the width of a number 2 pencil. And the lasers actually fire from, let's say, the distance from Washington, D.C. to Cleveland in 3.3 milliseconds.
Now, it's funny because that seems like it would have to be a powerful laser to reach that distance. But what I've heard is that it's a low-power laser. How is this possible?
You can describe it as a high-power laser and a low-power laser. It's relatively a high-power laser, but we spread the beam out so that when it reaches the ground, the energy density is much lower.
Is that done for safety reasons? Because I was wondering if I happen to be standing in the path of ICESat-2 when it's flying, would I be damaged if you were measuring my height on the Earth's surface?
No, it's safe for the public. It's been designed such that there's no risk to the public at all.
So the ATLAS laser is very sophisticated. How does it actually get better or more data for the ICESat-2 mission?
Sure. One of the differences between ICESat and ICESat-2 is that ICESat-2 splits the laser into 6 beams. That allows us to cover a larger area, and it also allows us to have more discrete measurements along the ground, which gives us higher granularity and data in those measurements.
So obviously ICESat-2 not only is using this more sophisticated instrument, but it's getting a significant higher amount of data.
Yes.
So how do you process the data on the spacecraft and get it to the ground stations?
Oh, that's pretty exciting. I love talking about this because it's pretty interesting. So we have a very sophisticated, I like to call it, map on board. It's actually the digital elevation model. And our receiver algorithm team, as part of our testing, they actually identify the area of interest based on where we are over Earth. And they're able to modulate the amount of data that actually gets time tagged and dumped to the ground based on where we are and how much data is needed in order to be able to make an accurate measurement.
You're really collecting data on the differences you see from this map.
Yes. So we're collecting data not only on the differences as the observatory takes measurements, but we're also modulating the amount of data based on the surface type. So if you are taking measurement over a flat surface, a relatively flat surface, then you would need less data than if you were taking a measurement over a surface that had a lot more differences in the terrain.
Now, is that primarily because you just don't want to generate a lot of extra data that's repetitive, or is that more of a capability issue? It would put strain on the instrument to basically take a new survey every time it flies over.
It doesn't necessarily put strain on the instrument, so the instrument actually collects the data. The difference is that the instrument itself is smart enough to know what data needs to be downlinked. And the reason why that's important is because our data is stored on the spacecraft, on the observatory, and there's not infinite space. So you need to be very strategic, and not only the data that you collect, but the data that you downlink, because there are resource constraints.
There's so much to be impressed about with regard to Atlas and ICESat-2, but what are you most proud of?
When I think about it, there are three things that I'm proud about with respect to Atlas. It's one of the largest and most sophisticated instruments that's been built here in-house at Goddard. It took a large team in order to build that instrument. We had about 350 people, and I can say that it's one of the best teams that I've ever worked with.
We are now about 30 minutes into the flight of Delta II carrying NASA's ICESat-2 spacecraft. Let's go back to NASA's Joshua Santora for more.
Hey, thank you, Stephanie. A great initial series of events. We've got a few more things to come. I'm now joined by Scott Messer, who is the United Launch Alliance Program Manager for NASA missions, correct?
Yes, that's correct.
Scott, congratulations to you, and thanks for joining me this morning.
Thank you very much.
So tell me about the mission so far. Obviously, we're not done. Well, there's still more to come, but how have things gone so far? Has it been according to plan?
It has. Everything so far looks really well. The trajectory was good. All of the timing of events were well, and so far it's a very nominal mission. We're very excited.
Awesome. And so what's coming up now? Obviously, we say we're not done yet. What else is there left to do this morning?
Well, so we've got one more one more firing of the second stage, and then we'll have a little bit of a coast, and then we'll separate the ICESat mission. And then following that, we'll have another burn and short coast, and then we'll separate the P-pods and the CubeSat. So again, everything is looking good so far.
Awesome. And so what does this mission mean for ULA at large? Obviously, every mission is special, but in another sense, like, this is getting the job done, business as usual. So what does this mean for ULA?
Yeah, so clearly with the last launch of the Delta II, this will be the end of an era, and we're certainly proud of the history and the record of the Delta II vehicle with 155 launches under its belt when we finish this one. It's had quite a record, and of course nothing happens without the people on the Delta II program. So we're very proud of the people, and we stand on the shoulders of giants tonight. With that, ULA presses on. This is our 130th successful launch, and so a lot of good stuff to come.
Awesome. And so thinking about the Delta II retiring, it's not the only rocket in the ULA family of rockets. So what's the future look like for ULA and providing service to spacecraft customers?
Yeah, so certainly we've got a full manifest next year and the rest of this year, actually, with our Atlas and Delta IV rockets. And we, got Vulcan coming online in 2020. That'll be a very exciting new vehicle, and a lot of good stuff, exciting stuff for ULA coming up.
Awesome. Scott, thank you so much for being here this morning. Again, we'll continue to monitor the progress of the spacecraft as we continue towards spacecraft separation. Congratulations to the ULA team, and Stephanie, we'll send it back to you.
Thank you.
Thanks, Joshua and Scott. Partnerships are very important to all NASA missions, and ICESat-2 is no exception. Joining us now is Franklin Fitzgerald to talk about the benefit of partnerships with companies like Northrop Grumman.
Thank you, Stephanie. As Stephanie said, we're talking about partnerships, and Northrop Grumman has a partnership with NASA with the ICESat-2 on several different levels. Tell us about them, Joe.
So we are responsible for the spacecraft bus. That's part of the LeoStar 3 product line that we make in Gilbert, Arizona. We also were responsible for many of the components that came together to make that bus, including the tanks from California and heat pipes from Maryland. Also the guidance and navigation and control CYRU that Northrop Grumman makes as well. We're pretty involved in that.
Now, this bus called the Leo Star 3, right, is basically the infrastructure, the body of the ICESat. And this is a tried and true satellite for Northrop Grumman, is it not?
That's correct. We've made quite a number of these buses over the past, specifically for NASA. These are the middle-size science, high-pointing buses. Specifically, the satellite is designed, the satellite bus, to point the instrument. So we have the wheels and the tanks and the propulsion that allow us to point the science instrument exactly where the scientists want it to go.
Speaking of tried and true, the Delta II vehicle, you've had some partnerships with ULA on that. Tell us about that.
We have actually, Northrop Grumman and its predecessors have been making the GEMS, the graphite epoxy motors, for many, many years. Actually, it turns out that the four that we just saw jettisoned after launch, that went very well. We've made, I think, about 1,000 of those strap-on boosters.
Now, partnerships right now and into the future, can you tell us a little bit about them before we get off?
Sure. We have and continue to be part of the cargo resupply mission for the International Space Station. That's probably one of our biggest efforts and has been highly successful. We also, though, are looking forward to the next version of that, the next contract for that's coming up, as well as we have and continue to make these large to medium science spacecraft. Currently, we launched Landsat 8, what was called LDCM, and now we're going to be working on, as we go forward, Landsat 9 and the JPSS mission.
Joe Whitaker, Northrop Grumman, Chief Engineer for the Space Systems Group, thanks for your time this morning.
Thank you, Franklin.
Stephanie, back to you.
Thank you, Franklin. Our Tori McClendon had the opportunity to speak with NASA's Director of Earth Flight Projects, Kathy Richardson. She was able to fill us in about why ICESat-2 is so important and how it fits in with NASA's other Earth science programs.
Thanks, Stephanie. So, Kathy, you oversee the Earth Science Projects Division at Goddard. Can you talk a little bit about your role?
Sure. So I'm the Deputy Program Manager, which means that at Goddard Space Flight Center, I'm responsible for all of the Earth science missions that are managed out of Goddard. So we have multiple missions. We have missions that are just in formulation, as well as implementation and operations. And of course, ICESat-2 falls under our program office.
So of course, your role does not end at launch. Can you talk a little bit about what happens after the spacecraft gets into orbit?
Right, so the spacecraft will have about 60 days where it's going through its commissioning phase. Once that happens, it'll go into its operational phase. And then we have a whole other organization that makes sure that they take care of it and that it's runs safely on orbit, and then it provides all of the data that it needs to. We also have an organization that collects all of the data, processes the data, archives it, and then distributes it to multiple users across the world.
So this mission has been, what, 10 years in the making?
At least 10 years. We've been working on it for quite some time, yes. And we've had multiple people who've worked on it for 10 years, even longer, trying to make sure that the whole thing comes together well.
And you yourself had a different role in this mission earlier on, is that right?
That's right. So for about 3 years, I was the instrument project manager, which meant that I was responsible for Atlas, which is the only instrument on ICESat-2. So that was really exciting for me.
So how excited are you to finally be here?
Absolutely very excited. So not only do I get to be here because of my current role in the program office, being able to oversee ICESat-2, but it certainly is very personal for me since I spent so much time working with the team and being able to launch. Seeing it all happen today is just really exciting.
I can only imagine. Well, thank you so much for joining us.
Thank you.
With that, we'll go back to you, Stephanie.
Has today's launch made you want to learn more about NASA? Well, Kennedy Space Center recently launched a new podcast series to give you behind-the-scenes look at what goes on. Today's launch director, Tim Dunn, and launch commentator, Mick Waltman, joined in on the fun.
I am the launch director for the Launch Services Program, and so sounds like a pretty cool job.
It does.
It is.
One of my favorite shows growing up was Star Trek, the
Star
original.
Trek.
Awesome.
The original.
Unfortunately, you will hear Tim wanted to be a certain character. I believe his name was Captain Kirk.
Captain Kirk. Who didn't want to be Captain Kirk?
That's a good question.
Well, that was me. I wanted to be Scotty.
It's all rockets all the time. Saddle up for our rocket roundup in this month's episode.
We are now 38 minutes after the successful launch of the Delta II carrying ICESat-2. Let's go back to Joshua and Mick to carry us through the on-orbit milestones.
Man, some good-looking guys in that Rocket Ranch promo.
Yeah, I think Tim and I look really good there.
Oh, it's only because I was out of frame. I didn't want to steal anything from you.
But you know, Josh, you made that really fun. I think that's a great way to get space information out to the public and share. And I'll tell you, Tim and I had a great time doing that podcast with you, and we're looking forward to seeing that and how it gets out in enthusiastic, excitement for people.
Yeah, that's something that I think people may not know just about engineers in general, about people who work here in general. People probably have a perception, I hope they have a perception, that NASA is a great place to work. And when you get around guys like you and Tim Dunn, the energy is infectious.
I appreciate that.
You can't hide it, man.
I appreciate that.
It's something that we love, and it gets me fired up, and it gets me excited to be here.
I tell you, we talked about teamwork earlier. I appreciate you saying that. Tim and I get very excited about the rockets we work with and the team we work with. It does take a team, and we talked about that, to do everything in this business. And being part of the Launch Services Program team and the United Launch Alliance team and the teams that launch these missions for the NASA agency is just really exciting. It's a passion we all have. And I think if you visit us at Launch Services Program or anybody that's in this business, one of the things that you will see is that passion and that positive aura around them, because they love their job. I mean, we love getting up and coming to work every day to do just exactly what we did today, which was get ICESat-2 on its way and get this final Delta II lifted off. As I said, it was emotional. You and I were talking a little bit off camera, and I'm still feeling a little nervous waiting for spacecraft separation, but watching that final Delta II lift off was just amazing. This week Tim has actually been running around at all of our launch readiness reviews, talking to everybody that's here, asking them what their Delta number is. We talked a little bit about that. I think Stephanie mentioned that the vehicles have been sequentially numbered since they started in the 60s.
Right.
And Tim's been asking. So my number is Delta 294.
294. And that's the whole Delta family. It's not just Delta 2s, just to make sure it's clear to our viewers.
That's correct. That's the Delta family dating back from 1960 to present. And 294 was the ICESat chipset mission, which was the beginning of the ICESat-2 mission that we talked about.
Awesome.
But on our team, we have some folks who've been working a lot longer than I have. Mr. George Lucian, who's part of the NASA engineering team, he was Delta 33 back in 1965. On the ULA team, our anomaly chief that you heard tonight working things with the team, Mr. Dave McFarland from ULA, he was Delta 132 at 1977. And, one of my mentors, George was one of my mentors, George Lucian, but another one of my mentors is still active with us today is Darren Bedell. Darren was Delta 178 in 1986. It was the beginning of a career that he's still with us, doing market analysis for Launch Services Program, finding new business, advisory work, and all kinds of things that keep Launch Services Program moving forward. So, especially those three gentlemen, I want to thank. You heard Scott say standing on the shoulders of giants. Those are definitely three that I admire and have built my career on. So I want to ask Josh, what is your number?
Sure. Yeah, it was interesting. The first meeting I was in this week, this has been something Tim's been talking about all week, and I really wasn't sure what the number meant at first because I'm new to the Delta family.
Yes.
So this is my first time really working launch, especially in capacity like this where I'm on console, and so I'm a 381. So Delta 2. Flight 155, launching ICESat-2, is my first Delta mission. So I'm a 381.
Well, you know what? As Tim said, the Delta family is large, even with this final mission that we just had. I want to welcome you to the Delta family.
Thank you. It's great to be here.
As a 381, and as a token of my appreciation, and hopefully you have many more launches, I think I'd like to pass on my Delta 2 pin
I appreciate that.
to you and welcome you to the Delta 2 family, my friend.
Hey, Mick, I appreciate this very much. I can't tell you how great it's been to work with you this week and getting ready for this launch. Congratulations to you. I know that you actually are a part of NASA's Launch Services Program. We'll kind of dive into what you all do in a little bit later on in the show. Stay tuned later in the show. Not only do we have, here in about 4 minutes or so, we have the second burn of the second stage to get ready for spacecraft separation. On screen there, you see an animation of the second stage. stage and the spacecraft there, still on their way. I believe that spacecraft has now, we launched going nearly due south. We have, I believe we've already passed over Antarctica, and we're now coming up towards Africa. So pretty interesting to think about the orbital path of this.
Yeah, we're hoping that, or we should be seeing when we get up to this T+47 minute, starting up the second stage engine and then heading over Madagascar for separation.
Yeah, so can you talk about why we have multiple second stage burns? That was one of my, again, being new to the family, you got to ask these kinds of questions, learning about orbital mechanics and things. Why have multiple burns of the second stage? Why not just fire one single burn and get where you're going?
Yeah, so tonight's mission was a two-burn mission for the primary spacecraft ICESat-2. The first burn got us into that initial orbit of a circular/polar orbit for us, right? This 7-second burn coming up is going to be that last little burn that gives us the velocity and boost to get ICESat on its way, making some slight inclination adjustments to that 92-degree inclination.
The second stage engine will ignite to start the second burn.
We're listening now to an update that's coming in.
The second burn will
I believe that's Patrick
only about
Moore's
7
voice.
seconds.
He's giving us an
Following
update. We're
completion
about
of the
3
burn,
minutes away from that second stage burn. So we're just trying to make sure we're staying up to speed on the updates coming through.
Yeah, so that second stage burn will provide that last little bit to get ICESat to where it's go. And then, of course, as you talked about earlier, we'll have 2 more burns. One to get into an inclination change to deploy our secondary payloads, our CubeSats. And then once those deploy, we will do a 4th burn over the Pacific Ocean, South Pacific area to bring the second stage back in for disposal so we don't leave anything out there floating. You know, all those are concerned about space junk. We want to bring that back so it's not there.
Absolutely, yeah. So again, interesting path, flying nearly due south with some minor adjustments with these second stage burns. We're taking a path, I think Stephanie mentioned this earlier, where we're going to cross over the same piece of land with our spacecraft, ICESat-2, the exact same piece of land every 91 days, which requires a very precise orbit.
Yes, and Delta II will provide that. I have total faith in this vehicle and what it's done over the years, and we will put the spacecraft where they need to be able to perform that science. And I think it's just amazing that we can see every part of the Earth in that short period of time and take measurements down to the millimeter level of our ice caps. And that's just, you know, we enjoy the rockets, but the science behind it is also exciting. And those guys that work the science missions on the spacecraft spend a lot of years of their lives putting this together and doing it, and it's just amazing to be part of that group to get these things going and this history that we're putting together for Mother Earth.
Yeah, so the orbital path today will take us over the eastern part of Africa. We deploy our spacecraft near Madagascar, and then we'll travel over the eastern part of Europe, and then we'll travel up and over Earth, and actually the end of this cycle will travel just to the west of where we are here. So again, the orbit jogs X number of miles to the west every orbit. And so eventually, 91 days later, it will pass over this specific spot again.
Yeah, we're basically flying north to south pole, right? And we're taking advantage of the Earth turning. And so as that does that, we stay in that polar orbit, and Earth turns, and so we get that full coverage of the Earth every 91 days. I think that's amazing. We're about 40 seconds away, I think, from second stage start, and we'll be listening to ULA's commentator Patrick Moore bring us through this as we get ready for this final burn.
Hydraulic system pressure is now coming up and standing by for ignition.
Again, you're watching an animation on your screen of the second stage in spacecraft.
And we have ignition on the second stage. Chamber pressure looks good and standing by for cutoff. And we have engine cutoff.
Awesome. So good calls there.
Hydraulic pressure now coming back down.
A startup and a cutoff. Obviously, the animation there, you see that as well. Again, just a great picture to kind of resemble what's going on up in space. Thankful to have those animations to help you get a chance to really kind of experience what's going on up there. Mick, we've talked about this this orbit around Earth. But there's a lot that goes in beyond the teams that are here on the ground for launch, which are still actively working to make sure that this is a success. There's a lot of teams that are still going to be working past today to make sure that the spacecraft is successful. So tell us about what's involved nationally or globally in taking care of a spacecraft.
So we talked about those teams that are involved: Northrop Grumman, Goddard Space Flight Center. Once the ICESat gets on orbit and gets its solar arrays deployed, the teams will be taking over. There are some of them located in Maryland and some in Virginia, and they will be monitoring the health of ICESat and prepping it to get started and commissioned up to start doing its science work. So as we talked about, not only a big team to take care of getting launch off today, a team to get the spacecraft on orbit and maintain that for the next 3 years.
Yeah, and I know that we had a good laugh. We were talking about some of the telemetry we get from around the Earth. There's a few sites around the globe that we rely on to help us track our spacecraft. And we had an incident with an animal not too long ago. Can you talk about that? Tell our viewers.
Yeah, so actually one of our sites, the Heart of Beastock site that we'll be using tonight to track the vehicle, we tend to send a live video from there to make sure everything's working. And during the JPSS-1 mission, we actually had a gazelle type come up to one of our cameras and kind of give us a look and make sure everything was working there this evening. And the team ran those tests earlier this week with Heart of Beastock and saw some wildlife out there also. So that's a pretty cool part of launching rockets and being part of the team.
Yeah, and I believe you said Heart of Beastock is in the area of Madagascar. Is that correct?
Yes.
Okay.
So.
Sorry to put you on the spot, but I feel like that was what we talked about.
Yes.
So we just got a word.
And we're starting to see, actually here in the MDC, Joshua, behind us, some video coming through of the ICESat-2 spacecraft on the front of the rocket.
Yes, we're hoping to be able to have the spacecraft separation live for you. It depends on the signal.
Absolutely.
It's not a simple thing to transmit a video back from space when you're traveling in the order of 17,500 miles an hour. So that's not to be taken for granted. But that's coming up in about 2 minutes. I believe we're expecting to hear word and hopefully get to see that spacecraft separate.
And actually, there's some live video right now from the front of the Delta II second stage, and hopefully we can maintain that signal. That will be really, really cool to see.
Yeah, so we are expecting things to get a little rowdy behind us when we see spacecraft separation or get confirmation. There are some other control rooms where they'll be more focused, kind of making sure that we get through spacecraft health, which doesn't come until later in the countdown. So if it does get a little noisy, that's what's going on, is it's excitement.
Yeah, this is, like I said earlier tonight, this is what it's all about right here, is the spacecraft and getting them on orbit to start performing their science. So this is really nice to be able to see the ICESat-2 spacecraft on the front of the second stage as it's in space, getting ready for final separation here in about a minute and 20 seconds.
Now approaching.
Yeah, and again, just to preview some of the other parts of the countdown, or part of the launch sequence that will be coming up the flight, we'll see spacecraft separation. A little bit later, we'll have the solar arrays deploying. And we'll also have a third burn of the second stage to get us in position to deploy the CubeSats, which is a big part. And then after that point, we're hearing we're going to get spacecraft health report, and that's when we're hoping to really kind of declare victory over the entire flight today.
Yeah, absolutely. Spacecraft separation is just another milestone. The teams will still be focused, waiting to hear the initial state of the spacecraft and make sure everything's good. So. I think the teams are looking like they're all standing up and getting a little excited here. I think everybody's on edge, still focused on what's going on. But we're getting closer and closer here to spacecraft separation, and glad to see that we still have live video.
Yeah, we're about 20 seconds out now, so we'll kind of just stand by and watch and listen.
And standing by for spacecraft SEP shortly. And we have good indication of separation of the ICESat-2 spacecraft.
Awesome, that is great. That's what we want to see. That motion there you see on your screen is the spacecraft drifting away from the second stage. So that looks good. Obviously, we'll get full reports later, but definitely like a lot of people breathing another sigh of relief. There's
yes.
several of those that happened today.
It's just another milestone. We still have a little bit more to go. And like we said, verify that solar panels are out and get that state of health. As you had mentioned earlier, they want to get into that light, 24-hour light, and be ready to go. So we're waiting to see that. We see the teams at the Remote Launch Control Center, NASA's launch manager Tim Dunn and his team celebrating the separation of ICESat-2 there. That's a very historic moment for this final Delta II.
Yeah, and I'm sure a lot of spacecraft folks, Goddard folks, Northrop Grumman, that are, again, another big sigh of relief. But I want to actually take a step back for a second and talk about the Delta II. So again, this was the final Delta II, 155th. But we were expecting the final Delta II was actually going to launch in 2011. When we launched the 2011, there was a Delta II mission, and we thought that was the last one. So, Mick, how are we here today with another Delta II?
Yeah, the teams went through this with our NPP mission here on the West Coast and Grail on the East Coast. We thought that was the end of Delta II. However, NASA still had some science missions out there, and United Launch Alliance kind of stepped up and said, we've still got some Delta IIs left. So we matched those up, and NASA's Launch Services Program was able to get OCO2, SMAP, JPSS-1, and ICESat-2 on the remaining 4 Delta IIs that ULA had. But what most people don't know is I think that they don't know that there's a 5th Delta II out there, or parts of a Delta II, I should say.
Most of one.
Most of one. We couldn't launch it, but there is some information we'd like to share on that with those parts that are available. And I think United Launch Alliance's Tori Bruno has an announcement for us.
Hello, Delta II fans. Just because we recently watched a Delta II liftoff for the last time doesn't mean we have to say goodbye. I'm excited to announce that the final Delta II rocket will soon take its place in the lineup of historic rockets located in the Rocket Garden at NASA's Kennedy Space Center Visitors Complex in Florida. The Delta II rocket has been a venerable rocket for NASA and civilian scientists, the U.S. military, and commercial customers throughout its almost 30 years of service. This program comes to a close with the final launch of NASA's ICESat-2, but its legacy will continue, and the Visitors Complex will help us keep the story of success of this much revered rocket in the hearts and minds of the public. The maiden Delta II took flight on Valentine's Day in 1989, successfully delivering the first operational GPS satellite into space. Since that first launch, Delta II rockets have launched 154 successful missions. Its resume includes several trips to Mars, as well as the planet-hunting Kepler, the twin lunar orbiting Grail spacecraft, 48 GPS satellites, and numerous commercial imaging and communication satellites. These tremendous achievements are a tribute to the dedicated team at ULA and our supplier partners that ensure mission success each and every launch. So, the next time you are in Florida, stop by the Kennedy Space Center Visitor Complex and take a selfie with the Delta II, and make sure and tag @ULA Launch.
So, Mick, what people just got to hear is that the fifth, the fifth Delta II, which they weren't aware of, is going to be on display, and they probably don't know either that you and Tim Dunn were a part in helping to really champion that effort.
Well, I tell you, Tim and I are very excited about that. We've been pushing for something like that for quite a while, to be able to share Delta II heritage with the public. Put it at Kennedy Space Center next to the sister Thor that's out there in the Rocket Garden. Man, that announcement just that made my night tonight, just to hear that we were going to be able to show off this blue beauty to everybody, and they could get a chance to experience the heritage of Delta II, the legacy of reliability, the heritages of success that Tori talked about with these number of missions that it's done, and how much Delta II has really played a part in the U.S. government and people's lives with all the scientific missions, commercial missions, the GPS satellites that are out there that have changed the way we do business today with our phones, our computers, and all that kind of stuff. Delta II has been just an amazing rocket, and I'm I'm just a little emotional to hear that announcement because I think that's just so great to have it right there where people can visit it.
Yeah, and that's a big congratulations to the entire Delta family, especially the Delta II family. I know that rocket garden is getting bigger and bigger, and it's becoming more and more beautiful. I think the more spacecraft and rockets we can add to the collection there, it's an inspiring place to be.
Oh, it is. It absolutely is. Just walking through the rocket garden and seeing all of the rockets that have come before and how we've built on those and how we've expanded and done great things as a humankind. To see Shuttle Atlantis on display there is just amazing. To inspire the next generation. That's what it's all about. You know, you talked about Tim and I in your podcast and being positive and energetic, but we're really out there just trying to inspire the next generation from those that inspired us to get into this business and continue doing what we do. So I'm very happy to hear that fifth Delta II will be on display for everyone to see and touch.
Yeah, and you'll notice on screen there, you see, again, that animation. Now, obviously, the spacecraft is now out of the picture here, which is expected, and you see the second stage there with the P-pods on board. Now, it's tough to tell where those P-pods are based on there. They are in that animation, but they're pretty small. They are CubeSats. We'll hear from the NASA Edge team here in just a few minutes, but before we get to that, we're going to actually track with hopefully solar array deploy announcements. I don't think we're going to get to see anything there, but we're going to get an announcement about that. And then we're also looking for the third burn of the second stage, which will happen here in about 10 minutes or so.
Yeah.
So, but Mick, I wanted to talk about the NASA Launch Services Program a little bit because this is a huge accomplishment for you all as well. That's the organization that you hail from, and you all are celebrating a giant milestone right about this time. This is your 20th anniversary of helping to successfully launch science missions and exploration missions to help us better understand our own planet, understand Mars, understand deep space. So big congratulations to you and the entire program.
I appreciate that. October is going to be our 20th anniversary since becoming a program at Kennedy Space Center, and this is a huge year for us. We've had 6 launches on 6 different vehicles, or will have 6 launches on 6 different vehicles. One left to go. We'll talk about that in a minute, but 6 launches, 6 different vehicles within 6.5, 7 months. That's a huge accomplishment for us as a program. We started the year off with GOES-S on an Atlas vehicle, the test mission on a Falcon 9. We then came back here to Vandenberg and launched InSight to Mars on a United Launch Alliance Atlas vehicle. And then we just recently launched Parker Solar Probe on a ULA Delta IV Heavy. You probably noticed a theme there that this ICESat-2 is our 5th of our 6 missions this year, and 4 of those 5 have been on United Launch Alliance vehicles. So again, getting back to the heritage of Delta II and reliability, we've been very pleased to partner with ULA on many of our scientific missions. And you know, once we get done this evening, the team's not done. They're actually going to move forward, and we've got to go work on ICON on the East Coast, launching off of Pegasus, our last mission for this year.
Yeah, and again, going back to just the quality of the work that your program does and that your team does, you all deal with a lot of customers, and everybody presents unique opportunities and challenges, and it's great that we have a fleet of options to choose from. It helps provide, I think you were talking about, it provides a competitive process to enable competition, to make sure that the taxpayers get the best deal, the best agreement for their money. For their money, yeah.
Absolutely. A launch services program has a fleet of vehicles that we can choose from, and part of our job is to meet with our spacecraft customers and understand their requirements and what they need, and then we take those and we look at the performance of the fleet of vehicles we have, and then we try to match up the spacecraft customer with the appropriate launch vehicle to get them on orbit to start doing their sciences. We have a great team of analysis folks, a great team of integration engineers. We just have a great team in launch services program that does that, and people are very passionate about that job and making mission success occur for their spacecraft customer.
Sure. So you are watching now live on your screen there an animation of what is the remainder of the profile for the final Delta II launch, the mission of ICESat-2. The spacecraft has separated, and we're waiting on confirmation. I haven't heard confirmation come in yet of solar array deploy. We're still waiting to hear that. And we also have the third burn of the second stage coming up here shortly. So we'll be keeping you up to date on what's going on with that. So can you talk a little bit about what's next for LSP? It's 20th anniversary. You guys are not resting and basking in the glory. You're working hard this year.
Yes.
So what's coming up for the future? I know that there are more big missions ahead.
Yes. So as I said, ICON is our next mission right up after ICESat-2. We'll be launching that on a Northrop Grumman Pegasus vehicle. That's a unique vehicle. It's an airdrop vehicle that launches from a modified L-1011, and we'll be doing that out of Cape Canaveral Air Force Station in Florida. But then the teams have to get, just because we finished that launch, the team still has a lot of work to do. We're working with our partners in Commercial Crew to try to get humans back on into space, since they're working with some of the same fleet of vehicles that LSP is familiar with. We have advisory missions that we're part of that we provide analysis and engineering services for. You can think of LSP as kind of a full-service engineering firm, right? But we work for NASA. We have NASA's interest at heart, and we kind of take a look and make sure that all our scientific missions and robotic missions and now working with our commercial crew partners, humans back to space and what needs to be done. So the team is always busy working on something, maintaining fleet insight on the launch vehicles that we have, working with new spacecraft customers. We talked earlier that, we started ICESat-2 7 years ago. So we've already started working with customers who we're going to launch in 2020 and 2021. So these things don't just come together this last month of launch. It takes a full team and a long process to make sure everything fits together and is working together for mission success.
Awesome. So thinking about the NASA Launch Services Program and our other teams on the ground here working today, what is this time like? Again, you've been on console before. You kind of know what the process is like. So we talked about the intent and focus prior to launch. Is that intent and focus maintained all the way through this time? Is everybody still really dialed in on what's going on? And what are the different teams working on?
Yeah, the engineering teams are still continuing to look at the vehicle performance and looking at how it performed versus the predictions that were done prior to launch, and just doing kind of an analysis, what we call a quick look of the vehicle to make sure everything performed well. Some of the team is still following the second stage here as we wait for this burn to come up and deployment of our CubeSats. We have team members looking at that. Some of the team is still following the spacecraft. We still haven't heard that solar array deploy or health check yet, but we're waiting to get that confirmation. And so the team's still focused and following that. As we saw earlier, they got to celebrate the spacecraft separation, but then they got right back and looking at the data and just making sure things were still going forward. We have to follow this mission throughout till we get that disposal burn for second stage. So the teams are going to stay on station and make sure this mission continues to end of mission.
Yeah, absolutely. So, Mick, people might be wondering at home, you're incredibly knowledgeable. We appreciate you sharing that breadth of knowledge with us. So what's your background in, and how did you get here today?
So, I started with Launch Services Program back in 2000. I came from, my early career was launching Atlas rockets with Martin Marietta, Lockheed Martin. And I started out as an electrical avionics engineer with Launch Services Program, and through my career I got the opportunity to join the Vehicle Systems Engineering branch, or Fleet Systems branch, and that was a huge opportunity for me to be able to expand my knowledge and learn the different fleets that Launch Services Program has. And I think that's one of the unique things in our program is you aren't just stuck on one vehicle. We get to work with all vehicles that we have and all the contracts we have and learn different things. So over my career, I've got to work with just about every vehicle that Launch Services Program has in their catalog. And, I'm glad to see Falcon 9 coming on board, and even some of our new entrants in our Venture Class series. And as we start moving forward with commercial resupply missions, and even some new folks that are out there that we're working with to see how they might be able to support NASA Launch Services Program, like Blue Origin and Virgin One and some of those. So it's just great to get out. The passion is there to just learn new things. And so I think every day that I'm part of Launch Services Program and have that chance to learn something new. I don't think learning something new is great, and we get that chance in LSP.
Awesome, great. Yeah. We are now about a little less than an hour and 8 minutes into our flight this morning, the final launch of the Delta II, launching ICESat-2 to explore polar ice sheets. We are monitoring the second stage still. There is one more burn and then some CubeSats to deploy. And like I said, we're going to check in with the NASA Edge team here. Once we get confirmation of that second stage burn, we're going to send it over their way to find out more about what those CubeSats are. It's really interesting, again, thinking about inspiring the next generation. You're going to hear about how there are students who are creating satellites to launch into space, which is just a wild concept.
And you know, as people hear about that in our education launching of NanoSats initiative, Alana, as we refer to it, and people just think it's college and universities.
Sure.
But we've actually had high schools build CubeSats. CubeSats are a unique way for students to learn project engineering, systems engineering, design, perform design reviews. NASA LSP helps some of these CubeSats with their initial PDRs or preliminary design reviews, or CDR, critical design reviews, and get them through those milestones of systems engineering. And so the students get to learn that and become part of a team. And then if they get a chance to launch one of these on a rocket, it's just an exciting time for them to see their project go from paper to launching something on orbit. And the other unique thing about CubeSats is they all have some kind of initiative that they're trying to accomplish while they're up there. And tonight, you know, our 4 CubeSats that we have on board, Dave, dampening and vibrations experiment is just a unique thing where they're testing tungsten particles as part of a mass dampener. So they're actually performing science and doing something with their CubeSat, right? ELFIN A and B, which are the electron loss and fields investigation CubeSats, they're studying constellations, looking at time domain changes. Again, doing some EMI, EMC work, right? And then SurfSat is looking at charged plasma on spacecraft materials. So they're using new materials and trying to learn different things. So these are great opportunities for kids and students to learn and provide initiatives for NASA.
Yeah, it's one thing to get to learn engineering by being hands-on. It's a whole other thing when your learning experience results in putting a functioning spacecraft into orbit to get to do some science research that way. It's pretty sensational.
Absolutely, Joshua. It's, again, trying to inspire that next generation to do what they want to do, and maybe one day even come work for NASA at Launch Services Program.
Hey, it sounds like a great way to spend a career.
Absolutely.
We are now getting word. We should be just about 30 seconds out from our third restart of our second stage. So we'll be bringing you that, and then we are going to pass it over to find out more about those CubeSats on board today. Again, really just a cool science.
Hydraulic system pressure is coming up as expected. Pressures look good. Standing by for ignition. And we have ignition. Standing by for cutoff. And we have engine cutoff.
So there we have cutoff, and as we said, you know, in addition to ICESat-2, we had these secondary payloads in the form of CubeSats tonight. These small satellites developed through our educational launch of Nanosatellites program, which gives NASA partners and students an opportunity to design, test, and fly their own small satellites. And Blair Allen from NASA Edge is with several of the team members standing by for deployment of their CubeSats on Alana 18. Blair?
That's right, Mick, and we're just really glad to be here. We're going to try something very bold to go through all of the Alana 18 CubeSats right now with their representatives. I'm starting right now with Ryan, who's representing ELFIN. Tell us a little bit about ELFIN.
Yeah, so the Electron Losses and Fields Investigation is a space weather mission. So we're looking to see how the sun influences the Earth's magnetosphere. And our 2 instruments, the energetic particle detector and the flux gate, you know, we'll see how quickly these storms dissipate or not, as the case may be.
Now, I understand that you were a late addition. You didn't know that you were actually going to ride on this mission. You had to do some last-minute work to get on.
That's right. Well, ELFIN A was on for the whole time, but we were able to put in ELFIN B. So that adds a whole lot of extra science for us. So we get to see how these storms change, both spatially and temporally.
And I'm sure when you get the science from this mission, how will it be made available?
It's all going on the website, and scientists all over the world will be looking at it. Open data policy.
Awesome. Thanks so much, Ryan. We're going to ask your colleague to step in from Cal Poly.
Certainly.
Thanks so much for being on the show. Sorry, just bear with us in our dynamic movement here. We want to cover these guys well. And so, Chris, you actually are from Cal Poly, and you worked on the Dave CubeSat. Tell us about Dave.
Yeah, so I worked on Dave. It's the damping and vibrations experiment from Cal Poly, and it has 3 beams in it that we excite and vibrate, and they all have tungsten particles in them at varying amounts, and we look at how they respond at every frequency through our sweep.
And basically, that technology would then be transferred to other spacecraft builders so that their instruments could be better protected during liftoff and flight?
Yeah. We're looking at mostly the deployment part, where you put out a boom from your satellite and making sure it doesn't shake your instrument apart.
Now, Cal Poly is, we've been to Cal Poly many times, and you guys have a long history of CubeSats. How long have you been working on CubeSats?
So I'm coming up on 4 years now. I'm in my grad year, but I've been working since my sophomore year at Cal Poly.
That's awesome. Now, have you worked with any of the other CubeSats that have launched so far?
Not the ones that have launched. I've got a few coming up, but ExoCube and ISX.
Now, is there like a CubeSat Maker Hall of Fame that you can get inducted into because you've worked on so many launched CubeSats?
I don't know.
We maybe should develop that.
Yeah.
Now, one more question I got to ask about Dave, because does Dave stand for something, or is it literally? I thought it was from 2001 when I heard it, but it actually is for a person, right?
Yeah. So Dave's one of our lab staff members, and he was actually a student working on Dave a few years ago.
And so he where is he tonight? Is he able to watch the launch?
I believe he's watching from the VIP viewing section.
Oh, I see. They name a CubeSat after you, and then you get escorted to the VIP area. Okay. Yeah. All right, see how this works. Well, thanks so much, and best of luck. Now, you go get back on console, get ready for the launch, and we'll bring on Alex. Now, Alex, you're from a very important school, UCF. We visit Orlando all the time to go see Kennedy. I know the school well, but you work on SurfSat. What is SurfSat?
SurfSat stands for Surface Charging Sat. It studies plasma-induced charging on different surfaces and how that discharge can damage components.
And that's perfect, because that helps protect spacecrafts from this electronic pulse. That's awesome. Now, another quick question. You've been involved with CubeSats how long? What's your history with the spacecraft?
It's been going on for a few years. I got brought on only the past few months to help bring it together and build it.
Did you imagine when you were filling out your application for college that before you were even done, you were going to be flying actual satellites?
No, getting into it, I had no idea what I'd be doing, but I love where I am.
And you got a really cool name with SurfSat. I mean, brilliant, right?
Yeah, it's an interesting name.
Yeah, love it. All right, well, I tell you what. Go ahead and get back on console. We're going to bring on Sean Daly, who's going to talk about the mechanism that they use to actually deploy these CubeSats.
Yeah.
Thanks for coming on the show,
my
Sean.
pleasure, Blair.
So listen, I see you're holding a significant piece of hardware.
Cradling.
Yes,
Yes.
cradling very, very delicately.
Yeah.
Now, I understand this is how the CubeSats actually make their way into space. Explain the P-Pod for us.
So P-Pod, this is one of the deployers we have. This is what we've used exclusively on Delta II up until this point, and the last time that we're going to be able to utilize it. So this is nothing more than a holder container unit.
Oh,
we had our first.
Oh, that's great.
All right.
So that would have been one of the Elfin CubeSats perfectly launched. That's great. So
100 seconds from now, we'll have a second of Elfin B.
And P-Pod launched, obviously.
Absolutely. So we're looking forward to this. Alex was just on here. They're going to be the final of those. And so up until this point, we've had 14 universities represented. We've had one partner to NASA, government partner to NASA. You saw that on JPSS-1.
Sure.
Yeah. And so we're happy to do this. We've had 3 universities tied for with 3 launches each. So Michigan, Cal Poly, and Montana State, and UCLA today. With that first and hopefully second one going very shortly, we'll be tied for, or we'll be there in second.
Yeah, I don't want to, be too pushy.
Right.
But this Hall of Fame idea that I just developed
Blair,
in the show,
I'm telling you,
we have to work on this because
you're going to be in there too,
yeah,
buddy.
See, that
That's
was
a
my
given.
subtle plan, but clearly you saw right.
You know, we know the truth.
Well, I'm hoping one day that I can develop a CubeSat as well. But you know, it's not just the it's not just the Peapod.
Right.
It's not just the CubeSats. You've had other partners that help this whole process because, if I understand it correctly, this process models exactly what NASA scientists and other commercial partners go through when they want to launch a satellite.
Exactly.
Tell us about those partners.
So these students that get to work on this are going to be doing it and going to be moving in directly. When they move in from this development process and go into the second
there you
one.
go. That's good. You love it, right?
Both of them. This is great.
Awesome. That's Elfin B, sorry.
Yep, Elfin B is moving on. So one more to go.
Yep.
Final of the Delta 2s.
Yeah,
Yep.
awesome.
So this is directly applicable to what they're going to utilize in their own world upcoming. And so this is the areas where we get to see the biggest pushes. We're seeing them now. Military's moving that way. Government's moving that way for diversified, smaller, allowing you to be able to do large science with a cloud of these.
Well, now that's interesting because you know, Elfin, I believe, is flying in formation.
Yes, exactly
and
right.
obviously these tandem satellites and these more complex CubeSats are being developed.
Yep.
Tell us a little bit about what's in store for the future for these.
Man, so it's moving on. It's not just CubeSats anymore. It's going to be CubeSats, and along with that, they're going to be moving up to ride shares. That you're going to see those. You saw that with Tropics coming up. Also, that's a larger version. It's going to get its own mission. So that's a team of satellites working together. You're going to be moving to ride shares, which are not just a kilogram, but somewhere in the nature of 300 to 500 kilograms, and a lot of science on those, and a lot more missions coming with them.
Now, would it be fair to say that despite the growth and the opportunity that you see in the CubeSat community, that you will always maintain these little
Absolutely.
the smaller ones, because it seems like there's tons of applications.
There definitely is, and you see it in the commercial industry, you see it across the government, and there's opportunities here to be able to be a lot of science and a lot of capability in a small package. This learning opportunity is what
There
you
we
need.
go. Yeah.
That's so good. That's so awesome.
Yeah.
Thanks, Blair.
I love these opportunities.
I
It's
do.
great. Now, was that SurfSat that
That
just
was.
launched?
So you had Dave and SurfSat on that one.
I tell you what, this has been real tremendous. We want to see CubeSats continue, obviously,
Yep.
but we've got to go. You go join your team
Thanks.
and
Appreciate
congratulate them for us. We're going to go back to Mick and Joshua because they have an update on the spacecraft. Back to you guys.
All right.
Hey, thanks, Blair. Obviously, we heard lots of good things. We're hearing good things now coming in.
We're actually hearing from spacecraft, we're hearing some toast on Countdown 1 right now.
And connect the world. Godspeed, Delta 2, and thank you for your almost 30 years of unparalleled excellence.
So you can definitely hear kind of a little bittersweet there in the voice.
Absolutely.
Definitely some tears will probably be shed this morning, not for sad reasons. Well, I guess sad to see it go, but definitely like fond memories,
But
great
very,
teams.
Very proud of the Delta 2 and what she accomplished today, this final launch. And we were hearing, Josh, from the spacecraft team that commands were sent for solar array deploy, and those were verified. So we're just now kind of waiting to hear from them still on their positive health status once they get into the sun, and we hear that. Yeah, this was a successful Delta 2 mission for the ICESat-2 mission, and I believe we just got the thumbs up from our NASA launch manager to give him a call on and hear what he's got to say.
This is NLM on the NLM net.
NLM, this is PAO. How are you doing today?
I'm doing great. How are you doing, Joshua? Oh, am I talking to Mick now? It sounds like.
We're both here. Mick couldn't
Wonderful.
keep from saying congratulations to you as well. Tim, congratulations to you and the entire team. Obviously, a huge success today. Everything we heard was great. So can you characterize the launch for us?
Wow. That's really what I can say is wow. It was a thrilling day. It really was. We got a little bit behind in some of our pad closeouts in getting the MST tower rolled and getting the pad ready. But the ULA team is absolutely amazing. We pressed ahead and got into the countdown sequence and continued to make up time as we moved forward through the countdown. And by about 20 minutes prior to our first targeted T0, we had completely made up the entire almost 2.5 hours of delay time that we'd had. So just an incredible performance by the combined government and contractor team to get Delta II ready with its precious ICESat-2 spacecraft and get it launched.
Awesome. Yeah, you all made this look easy. This is rocket science. It is not easy, but the team looks like they just did a great job pulling together today. But on a personal level, Tim, we know that you love the Delta II. Obviously, you are committed to every mission and do a phenomenal job. So what's this one for you personally?
Besides being excited, what does it mean to you personally?
Well, obviously, I'm a little bit sad. I'm thrilled with mission success and that we were able to close the chapter on Delta II with a huge success of an incredibly important science payload. ICESat-2 is going to do cutting-edge scientific data gathering. The precision measurements it's going to make from space are just going to be incredible. So to be able to say that we launched this very important science mission on the final flight of the industry workhorse is just a huge accomplishment for the entire team. And so I have a lot of personal feelings about Delta II, but I'm really just a very small part of the entire team. And I'm just proud, honored, humbled to be part of this team that gets to close the chapter on this incredible rocket.
Tim, I appreciate those words. I don't want to keep you. I know you want to go celebrate with your team. Again, congratulations to you, to Launch Services Program, to Goddard, to Northrop Grumman, to United Launch Alliance, and the U.S. Air Force. A great morning and a beautiful launch.
Great. Thank you so much.
All right, so I think that's actually going to do it for us here today, Mick. It has been a pleasure to be here with you. I appreciate you joining me. We've had a blast early morning, but worth it.
Yes,
and
very much,
we'll go ahead and send it back over to Stephanie.
Yeah, I want to say thank you to you real quick before we do. It's been a pleasure here with this final Delta II, and to echo Tim's, it's a teamwork, and I appreciate the PAO team also for getting the word out on this final Delta II. So thanks for having me here this morning.
Our pleasure. Stephanie, back to you.
Thank you both so much. It was a beautiful launch, and we really appreciate all of those of you who stuck with us through the entire launch broadcast. To learn more about the Earth's icy areas and how these areas are changing seasonally, please visit www.nasa.gov/ICESat-2. I'm Stephanie Martin, and from all of us here at Vandenberg Air Force Base, thank you for joining us, and we will leave you with a replay of that beautiful launch.
15,
Stopping, go.
14,
Green board.
13,
There's
12,
that green board call.
11,
that is great.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff of the final Delta II, launching nearly 3 decades of science research and exploration missions, lifting ICESat-2 on a quest to explore the polar ice sheets of our constantly changing home planet.